This week on Cumulus on Cloud, we're going to talk about cloud security as it applies to migrating to cloud. Now let's be honest, nobody wants to talk about security. This is the last thing on anybody's mind. We know it's important, but really the more important things to most of us is getting our job done, getting our applications running, getting our applications built and put into the cloud somewhere so that customers can get access to them. And we want to make sure that customers can get access to them. So security almost seems anathema to the actual process of getting our applications built. But the reality is we have to think about security, and we have to start embedding security into our processes if we're developing our own applications from the very beginning of that development process. And if we're using third-party tools, we have to think about how we interact with them in a secure fashion. There are a number of different topics in this space. We've touched on some of them in some of the other sessions recently, but really we have to start thinking about it from the base level up. If we're using virtual machines, for example, we have to think about how virtual machines themselves can be more effectively secured. We have operating systems that get loaded into a virtual machine, and once they're loaded, they are statically there for a long period of time. Often a virtual machine that gets deployed from a classic enterprise application into the public cloud lives with the same kind of life cycles that those applications had. We see people posting on Twitter and Facebook and other places how they have a server with 1,000 hours of uptime, or even worse, 1,000 days of uptime. In most cases, there have been no patches applied, there's been no security update applied to the application, to the infrastructure, to the operating system. And while it's amazing that the system can run that long without crashing or breaking in some other fashion, it's also a problem that we think it's a good thing to run an application for that long. Now, part of this comes from the way enterprise applications used to be built. They were built to never turn off. They were built to always be run 24/7 and just always be available. And that availability was both a benefit to the end users. Any time of day that they needed the application, they could get access to it. But it also created a real problem for the operators of the underlying infrastructure because they weren't allowed to turn the system off. And so it became a goal to never turn the system off. What we've seen in the cloud native space is this shift to saying, well, how about I just make it easier to break the application at any time and have it automatically recover for itself. And especially if I think about scale as adding more pieces of the puzzle and potentially pulling old ones out when I don't need them anymore, you can see how the models behind cloud native scale changed the interaction of operating the systems underneath. But that also made it easier to potentially secure those new resources, because if I found a security bug, I already had a mechanism in place to deal with that migration to the new version. And this was really the key. The ability to migrate to the new version of something is what allowed security to potentially become better in the cloud native space. Now, I say potentially because, again, we still have to think about security. And while we're starting in the virtual machine space and we're starting to think about operating system level security and updates and the resiliency at that level, the next step, even in the virtual machine space, is to think about how our application is secured. How are we dealing with end users accessing that application, whether they be public end users, so our customers for customer service type reactions or interactions, or even our internal users or other systems interacting with those environments in potentially a multi-service or microservice type architecture. We're seeing the ability to now start thinking about mutual authentication, not just the classic web service authentication that I think we've all seen. You go to your bank and it says, yes, I am your bank. And in fact, we can now look in our little browser bar and it says, this is how I was secured, and I am in fact TLS secured within that window. That's great. That means that the remote side is who it says it is. But how does the remote side know who you are, other than by you giving it a password? But we're already not providing an end-to-end encrypted path. We're providing effectively a one-way encrypted path. What if we can authenticate both ends? And we're seeing more and more of that class of service functionality coming into the cloud native space. And I think by correlation, we can actually apply those same technologies into our classic enterprise space, although there is a question of how we automate that. In the cloud native space, one of the nice things is we can secure those communications automatically because the whole environment is effectively designed around the concept of automated deployment, automated delivery, automated upgrades and downgrades if necessary of resources. We've also designed the interactions between those services to be as automated as possible, and that's what's getting all of the buzz. Tools like Istio and Linkerd or Linkerd's replacement called Conduit, which is effectively Linkerd 2.0, are tools that provide that kind of authentication engine embedded into the system. And that sort of improves the overall security of our application because we can say that at least amongst the application resources, both ends can say who they are, and we can agree that both of them are both correctly defining their resources. That's a very important part of this. I think we're going to see that start to expand out of the data center and into the end user space as well, so that we have the ability to mutually authenticate both ends of a connection all the time. This will dramatically improve security as we think about the internet at large. And as we get to Internet of Things, being able to have those edge devices authenticate themselves as an actual appropriately communicated device is going to become even more critical as the number of connections continues to expand and increase over time. So security is something that we can think of from that just sort of general patching level. We can start thinking about security in terms of how we interact with those resources, centralizing the login authentication processes, even using SaaS services to do that is another aspect of that security domain that we can start thinking about. How do I make sure that my users, if I'm in an enterprise, how can I make sure that my enterprise credentials get moved into the cloud in an appropriate way, and I'm only giving resources access to the services that I need? Many of the cloud providers, actually I would say all the cloud providers, have at least a minimally dense identity and authentication management tool, IAM set of tools. And some of them are so complicated that I think they actually create new security issues and new security concerns, because how do I determine what resources I need to give somebody? It's very easy to say, oh yes, I'm using identity and authentication management, but I've given all of my users all of the access that they would ever possibly need and then some, because it's too hard to figure out what those underlying security mechanisms need to look like, what those interactions need to start looking like. So while IAM is very important to many environments, it is also a bit of a burden on many environments because most people don't have a clear policy map for what any one user should be able to get access to in any one environment. Now, there are policy models that are being added to the system to make it a little easier to differentiate between those two domains, but that doesn't mean that it has resolved all of the problems that people are going to see. And it is yet another area that we really have to start paying attention to as we move into the cloud, making sure that our IAM credentials and policies and policy models for resources and users of the system are appropriate and we're not giving away too much access whenever possible. Restrict it first, find where the gaps are, and deal with those breaks after the fact by using policy models that can be updated instead of individual policy descriptions on a user-by-user basis. That's really the key for managing that aspect of security. So we've talked about a little bit about network access security using things like mutual authentication, but we're also seeing, of course, the continued use and value of VPN services, of firewall services. All of the classic network security domains still apply and still are appropriate. They are defense in layers type technology, so it's not good enough to just have a VPN and a firewall. You have to think about, again, authentication processes, access restriction processes, and many of the newer infrastructure tools are actually starting to provide policy for networking rather than having to describe specific endpoint resources. Many application developers actually got used to having to define IP addresses as access credentials for resource communication. We can take care of that kind of access with mutual authentication, and we can actually now include policy to say if it's mutually authenticated, it can still be compared now to a policy to determine if the two endpoints are even allowed to talk. So we're seeing more of that class of infrastructure as well. And the last domain that we have to think about when we think about security, of course, is our data. Now, I don't think there's a cloud provider out there that doesn't provide data in flight and data at rest encryption between the block storage sorts of environments that they have. And so that's sort of the first pass at it. But we also have to think about the other services, especially the network accessible, or better yet, REST API or web accessible resources in the cloud for storage perspectives. There have been so many breaches recently when people look at the news about an S3 bucket, an Amazon S3 bucket, not having been secured. Is it possible to secure them? Of course. Is it even possible to programmatically secure them so that every time somebody wants access, as long as they're able to prove how they're actually presenting that access, whether it be programmatically or as an end user, they can get a set of credentials that's appropriate to just that one request. So we can really lock down those resources very tightly, and it's very, I would say it's straightforward to implement the functions that allow those sorts of one-time use password functions to give access to a resource that I think it's effectively negligent to not implement that. If you're going to put data of any nature, whether you consider it sensitive or not, if you're going to put data on the cloud, don't just put it in an unencrypted, unauthenticated space if you can help it. Just because it's good to be able to provide the restrictions if they become necessary, or to at least understand who it is that's accessing the resources that you've put there. These are all important aspects to the system and things that we can implement. So from a security perspective, we can think about the infrastructure security from the compute perspective, managing VM security, managing even how our containers are secured, all the way up through to storage and network interaction securities. But let's not forget the most important part of all, which is our application itself. We should be doing all kinds of static and dynamic checking on resources. There's a technology now called fuzzy detection as well, which says, well, I might be running my application to look for security leaks, but what if I don't know what kinds of input somebody might try to throw at my machine if they can get access to it? So let me use something that tries to fuzz the input, make it a little less obvious what those inputs might be, maybe do even longer strings than you ever thought you might apply to the input, things of that nature, to, again, try to understand how the system can behave or how the system is going to react to someone trying to break in, because that's really what we're trying to protect against is the malicious user attacking the interfaces of your application. So being able to ensure security at the application level, being able to ensure security at a bundled application level. So in the container space, there are now container registries that can consistently and constantly scan through the current container images looking for potentially vulnerable libraries based on published CVEs or basically issue reports about security components. So we can actually secure at the level of looking at what is in our repositories and our container registries and making sure that those resources are at least up to date, rather than deploying something that might have a security vulnerability exposed within the application itself. If it gets deployed, let's catch those things while they're still static, while they haven't actually been put into public use, or if they have, that we can capture them and understand where they are so that we can replace them rapidly using more modern cloud-native techniques whenever possible. So security obviously has a huge number of different implications, a huge number of different resources and thoughts that need to be applied to it. This is just sort of the top-level view of things to start thinking about in terms of security. There's a lot more that we'll be covering in the future. Well, folks, thanks for watching. If you liked it, don't forget to like it. Hit that thumbs up button. We always like to know that we're doing a good job. Don't forget to share this with your friends, and just to make sure that you get the latest and greatest episodes that we release, hit that subscribe button, and don't forget to hit the little bell next to it so that you actually can get notified when they come out. Thanks so much for joining us.